Imagine staring up at the night sky, tracing constellations as you've done 1,000 times before, when suddenly a star that shouldn't be there flickers to life. It burns impossibly bright, then vanishes without a trace, leaving astronomers scrambling for answers. This isn't science fiction. It's just one of the countless cosmic mysteries that defy everything we think we know about the universe. Out there, beyond the comfortable glow of familiar stars, space is teeming with phenomena so bizarre they seem ripped from the pages of a fantasy novel. Unexplained explosions that outshine entire galaxies, planets that rain molten glass, black holes spinning at impossible speeds. These aren't anomalies. They're glimpses into a reality far stranger than we ever imagined. For centuries, we've mapped the heavens with tidy rules. Stars burn, planets orbit, and light travels at a constant speed. But the deeper we look, the more the cosmos laughs at our assumptions. Take the case of Tabby's star, a sun-like star that dims unpredictably, as if something massive or something unnatural is passing in front of it. Or consider the Great Attractor, an invisible force dragging thousands of galaxies toward it at breakneck speed, defying all known laws of gravity. These aren't just curiosities. They're cosmic puzzles begging to be solved, each one rewriting the textbooks of astronomy. Tonight, we're diving into 25 of the most jaw-dropping, head-scratching events ever witnessed by astronomers. From rogue planets hurtling through the void to celestial objects emitting mysterious radio signals, the universe is stranger than fiction, and the best part. Every discovery pulls back another layer of the cosmic curtain, revealing how much we still have to learn. So buckle up. By the time we're done, you'll never look at the night sky the same way again. The night of August 15, 1977, seemed ordinary at first at Ohio State University's Big Ear radio telescope. The machine was quietly scanning the cosmos for signals, routine work in the search for extraterrestrial intelligence. Then, out of nowhere, a burst of noise erupted from the speakers. A narrowband radio signal, 30 times louder than the background static, blared for exactly 72 seconds before vanishing as abruptly as it appeared. Astronomer Jerry Amon, reviewing the data days later, circled the anomaly in red pen and scribbled one word beside it. Wow, it was a moment of stunned disbelief. The signal matched every criterion scientists had for an intentional alien transmission emanating from deep space near the constellation Sagittarius. At the precise frequency hydrogen absorbs and emits energy. A frequency any advanced civilization would recognize as cosmic breadcrumbs. Yet despite decades of searching, the signal never repeated. No natural phenomenon, no pulsar, no comet, no known cosmic event has ever explained it. Some researchers argue it could have been a reflected human transmission, bouncing off space debris. Others point out Earth's own satellites and aircraft don't emit such focused, powerful bursts. The most haunting theory, that it was a deliberate, one-time beacon, a cosmic hello from a civilization that either moved on or fell silent. To this day, the WOW signal taunts astronomers. New telescopes like the Allen Array scan its origin point routinely, hoping for an echo. Meanwhile, scientists debate, was it a fluke or a missed connection? A natural oddity or proof we're not alone. One thing's certain. It rewrote our understanding of how strange the universe can be, and it set the stage for every unexplained signal since, a ghostly whisper from the void we still can't ignore. In the constellation Cygnus, about 1,400 light-years from Earth, a star behaves like nothing else in the known universe. KIC 8462852. Better known as Tabby's star, after astronomer Tabetha Boyajian, who led its investigation, does something astronomers have never seen before. It flickers, not in the gentle rhythm of a planet passing in front of it, but in chaotic, dramatic dips that sometimes block up to 22% of its light. To put that in perspective, even a Jupiter-sized planet would only dim a star by about 1%. Whatever's orbiting Tabby's star isn't just unusual, it defies every model we have. The mystery began when citizen scientists combing through data from NASA's Kepler telescope flagged it as bizarre. Unlike other stars which dim in predictable patterns, Tabby's star seemed to have no rhythm at all. Its light would plummet erratically, sometimes for days, other times for weeks, with no clear explanation. The internet exploded with theories, the most tantalizing being the idea of an alien megastructure, a hypothetical Dyson sphere built by an advanced civilization to harness the star's energy. Imagine a vast network of solar panels, so immense it occasionally blocks the star's light from our view. It was a thrilling thought, but scientists urged caution. The universe rarely serves up easy answers. Years of follow-up observations peeled back layers of the mystery. Infrared studies revealed something unexpected. The star was surrounded by vast clouds of dust, fine enough to scatter light in strange ways. This wasn't the clean, geometric shadow of a megastructure. It was the messy fingerprint of cosmic debris, possibly from a recent planetary collision or a swarm of comets. Yet even this explanation feels incomplete. The dust doesn't fully account for the star's long-term dimming, which has faded by nearly 3% over the past century. That's another puzzle entirely. Tabby's star remains an enigma, a cosmic riddle that refuses to surrender its secrets. It's a reminder that for every answer we find, the universe has 10 new questions waiting. Whether it's dust, asteroids, or something beyond our current understanding, this star challenges us to think bigger. After all, if something this strange exists in our galactic backyard, what else is out there hiding in the dark? For decades, a shadowy object has haunted Earth's orbit, not in the silent emptiness of space, but in the vivid imaginations of conspiracy theorists and science fiction fans alike. They call it the Black Knight satellite, and its legend is woven from equal parts mystery and misunderstanding. The story goes like this: an ancient alien probe, thousands of years old, has been silently circling our planet, watching human civilization rise and fall. Some claim it's been transmitting signals since before the invention of radio. Others insist NASA has covered up its existence. But where did this tantalizing myth actually begin? The truth is far less extraterrestrial, but just as fascinating. The earliest whispers of the Black Knight emerged in the 1950s, when newspapers misinterpreted leaked details about early satellite launches. Then, in 1960, a piece of thermal insulation broke loose during a Mercury space mission, drifting in orbit like a phantom. Astronauts reported seeing it, a dark, tumbling object against the void, and the legend gained new life. But the most famous evidence came decades later, when a 1998 Space Shuttle Endeavour mission captured footage of what appeared to be a strange, angular object floating near Earth. The internet erupted. This, believers declared, was undeniable proof. NASA explanation was mundane. The object was a lost thermal blanket dislodged during an earlier spacewalk. Yet the myth refused to die. Why? Because the Black Knight taps into something deeper, our collective fascination with the idea that we're not alone, that some intelligence out there has been watching us all along. The legend snowballed, fueled by misidentified space debris, grainy photographs, and a famous but misunderstood radio signal from the 1920s, long before satellites existed. That signal, detected by pioneering inventor Nikola Tesla, was likely a natural pulsar or distant quasar, not an alien broadcast. What's remarkable isn't just the persistence of the myth, but how it's evolved. The Black Knight has inspired novels, films, and endless online debates. It's become a cultural shorthand for government secrecy and cosmic mysteries. And while astronomers roll their eyes at the idea of an ancient satellite, pointing out that orbital mechanics would have dragged any object into Earth's atmosphere long ago, the legend endures. Maybe because it speaks to a truth deeper than facts. The universe is vast, and we yearn to believe we're part of something bigger. Whether it's space junk or a story we've built from shadows, the Black Night reminds us that sometimes the most compelling mysteries aren't written in the stars, they're written by us. Deep in the vast expanse of space, cosmic explosions unleash more energy in a single millisecond than our sun produces in 80 years. These are fast radio bursts, blistering, mysterious flashes of radio waves that streak across the universe, vanishing before astronomers can even blink. First discovered in 2007, these bursts last barely longer than a snap of your fingers, yet they travel billions of light years to reach us, carrying clues about the most extreme environments in existence. The strange part, we still don't know what creates them. One of the earliest and most famous bursts, FRB 121102, flipped everything scientists thought they knew. Most fast radio bursts are one-off events, cosmic lightning strikes that never repeat. But this one, detected in 2012, did something unprecedented. It pulsed again and again, flashing from the same patch of sky over 3 billion light-years away. Suddenly, astronomers realized these phenomena weren't just random blips. Some had patterns, some had origins we might actually trace. The leading theory points to highly magnetized neutron stars called magnetars. Imagine a star so dense that a teaspoon of its material would weigh 1 billion tons, spinning furiously with a magnetic field 1 trillion times stronger than Earth. When these cosmic powerhouses experience starquakes or magnetic eruptions, they could unleash the titanic energy needed to produce FRBs, but not all bursts fit neatly into this box. Some repeat at irregular intervals, while others appear to come from regions with no obvious magnetar activity. That's where wilder theories creep in: colliding black holes, evaporating primordial holes, or even, controversially, extraterrestrial propulsion systems. Then there's the matter of localization. In 2019, astronomers pinned another repeating burst, FRB 181214, to a galaxy surprisingly close, just 500 million light-years away. Unlike the distant, ancient sources of earlier bursts, this one originated in a spiral galaxy similar to our Milky Way, suggesting FRBs might not require exotic environments after all. Could they be more common than we thought? Every new detection adds another puzzle piece, yet the full picture stays frustratingly out of reach. What makes fast radio bursts so tantalizing isn't just their mystery, it's what they reveal about the universe. As these signals travel, they pass through clouds of ionized gas, distorting in ways that let astronomers map the invisible matter between galaxies. They're cosmic messengers carrying encoded maps of the cosmic web. And with hundreds detected so far, each one a fleeting, brilliant enigma, they remind us that the universe is far from quiet. It's screaming across the radio spectrum, and we're only just beginning to listen. Somewhere beyond the veil of our own galaxy, a cosmic phantom is pulling thousands of galaxies toward it with irresistible force. Meet the Great Attractor, an invisible gravitational behemoth so powerful it warps the motion of everything around it, bending the paths of entire galaxies like a celestial puppeteer. Hidden behind the dense star clouds and dust lanes of the Milky Way's zone of avoidance, this enigma has taunted astronomers for decades, resisting observation while dominating the movement of our local universe. The story begins in the 1970s when scientists mapping cosmic microwave background radiation noticed something odd. Galaxies in our galactic neighborhood, including our own Milky Way, weren't moving randomly. They were all streaming toward a single point in space near the constellations Centaurus and Hydra, racing at over 600 kilometers per second toward nothing visible. The culprit lay obscured by the thick disk of our galaxy, where interstellar dust and gas block nearly all visible light. Early attempts to peer through this cosmic curtain failed, leaving astronomers with only indirect clues: gravity's fingerprints on everything it touched. Then came a breakthrough. Using X-ray telescopes to cut through the obscuring material, astronomers discovered the Norma cluster, a massive gathering of galaxies approximately 250 million light-years away. Here, gravity's pull was strongest, suggesting this might be the heart of the Great Attractor, but the math didn't add up. Even this supercluster wasn't massive enough to explain the colossal tug we observed. Something even bigger had to be lurking in the shadows. Enter the Shapley supercluster, an almost unimaginably vast collection of galaxies over 4 times more massive than the normal cluster, lying 650 million light-years beyond it. This colossus, the largest known structure in our cosmic neighborhood, may be the true source of the Great Attractor's pull. Yet some researchers argue this still doesn't fully account for the galaxy's motion, hinting at an even more provocative possibility: dark flow. This controversial theory suggests galaxy clusters are being dragged towards something beyond the observable universe, perhaps a region of space with such extreme density that its gravity reaches across cosmic horizons we can't yet see. What makes the Great Attractor so humbling is how it underscores the limits of human perception. For all our telescopes and technology, we're still deciphering the universe's secrets through a keyhole, glimpsing fragments of a puzzle we may never fully solve. Whether it's a hidden supercluster, an unseen cosmic web, or something even stranger, this gravitational riddle reminds us that the universe doesn't just hold mysteries at its edges. They're woven into the fabric of everything around us, invisible and undeniable. In October 2017, an astronomer in Hawaii spotted something that shouldn't exist: a visitor from beyond our solar system, tumbling through space at breakneck speed. Named Oumuamua Hawaiian for scout, this interstellar intruder wasn't just the first of its kind ever detected. It defied every expectation. Most asteroids and comets follow predictable paths shaped by gravity and the physics we've studied for centuries. But Oumuamua didn't play by those rules. It was small, dark, and eerily elongated. Some estimates suggested it could be 10 times longer than it was wide, a cosmic cigar hurtling through the void. And then came the real shock. As it raced away from the sun, it sped up. That acceleration sent shockwaves through the astronomy community. Normally, when a comet nears the sun, heat vaporizes its ice, creating a glowing coma and tail that push it slightly faster, a process called outgassing. But Oumuamua showed no coma, no tail, no visible signs of outgassing at all. So what propelled it? Some scientists proposed hidden reserves of hydrogen ice evaporating invisibly in the vacuum. Others pointed to solar radiation pressure, light itself pushing against the object's surface, but the math was shaky. The required force was far stronger than typical radiation pressure could explain. That's when Harvard astrophysicist Avi Loeb dropped a bombshell. What if Oumuamua wasn't natural at all? Loeb's controversial hypothesis that Oumuamua might be an alien light sail, a piece of extraterrestrial technology riding sunlight like a ship's sail catches wind, ignited a firestorm. Critics dismissed it as sensationalism, arguing that extraordinary claims require extraordinary evidence. They pointed to the object's apparent lack of artificial radio signals and its chaotic rotation as signs of natural origin. But Loeb countered with the data. The acceleration profile was too precise, too clean. No known comet had ever behaved this way. Even the shape, though not impossible for a natural object, was statistically bizarre. Most asteroids are lumpy, not needle-like. The debates raged, but one thing became clear. Oumuamua forced us to confront how little we know about interstellar visitors. Since its discovery, astronomers have spotted more, like the comet Borisov in 2019, a far more conventional object with a clear tail. But none have matched Oumuamua's strangeness. Was it a fragment of a shattered planet, a rare type of cosmic iceberg, or something beyond our current science? The truth is, we may never know. By the time telescopes turned toward its trajectory, it was already too distant, vanishing into the dark like a ghost. What remains is the legacy of that fleeting encounter, a reminder that the universe is capable of throwing curveballs we can't yet catch. Whether natural or artificial, Oumuamua challenged our assumptions, proving that the cosmos still holds surprises waiting just beyond the edge of our understanding. And with every new interstellar visitor detected, astronomers watch closely, wondering, will the next one be stranger still? Picture the universe as a vast, rushing river, with thousands of galaxies caught in a current they can't resist, all flowing toward something unseen. This is dark flow, one of cosmology's most unsettling mysteries. It started when astronomers mapped the motion of galaxy clusters and noticed something impossible. They weren't just drifting apart with the expansion of the universe. Hundreds of them were racing in the same direction at staggering speeds, as if pulled by an invisible hand. The implications were staggering. Either our understanding of gravity was fundamentally wrong, or something colossal lurked beyond the edge of everything we can observe. The first clues emerged in 2008, when a team analyzing data from NASA's Wilkinson microwave anisotropy probe noticed a strange pattern. Galaxy clusters weren't moving randomly. They were streaming toward a single point in the sky near the constellations Centaurus and Hydra, the same general direction as the Great Attractor, but much farther away. The scale was mind-bending. These clusters were spread across billions of light years, yet their motion suggested a gravitational pull from something even more distant. Something beyond our cosmic horizon. That's where things get controversial. According to standard cosmology, matter should be distributed evenly on the largest scales, with no single structure massive enough to exert such a pull. The leading theory, dark flow, might be evidence of a neighboring universe, a bubble of space-time beyond our own, exerting gravity on our galaxy clusters like a cosmic magnet. It's a radical idea, one that challenges the very notion of our universe's boundaries. Skeptics, however, argue the data could be an illusion, perhaps distortions in the cosmic microwave background or errors in measurement. Yet the mystery deepens. Follow-up studies using X-ray telescopes found the flow extends even farther than initially thought, with some clusters moving at over 1,000 kilometers per second. If another universe is out there, its gravity would need to be unimaginably strong to reach across the void. Alternatively, dark flow might hint at exotic physics like quantum fluctuations from the Big Bang, imprinting directionality on the cosmos itself. What makes dark flow so thrilling isn't just the science, it's the audacity of the question it forces us to ask. Are we alone in the multiverse, or is our universe just one leaf caught in a much larger cosmic wind? Until we have better tools like the next generation of space telescopes, the answer remains tantalizingly out of reach. But one thing's certain, the universe still has secrets that defy even our boldest theories. And dark flow might be the biggest clue yet. Imagine a universe so vast that for every grain of sand on Earth, there are 10,000 stars. Now consider this, with billions of potentially habitable planets, why haven't we found a single trace of extraterrestrial intelligence? This is the Fermi paradox, the crushing silence that contradicts everything probability tells us. The question first struck physicist Enrico Fermi during a casual lunch in 1950 when he turned to colleagues and asked, "Where is everybody?" If life were common, he reasoned, the galaxy should have been colonized by now. Yet the stars remain eerily quiet, and that silence has haunted scientists ever since. The Drake equation, framed by astronomer Frank Drake in 1961, attempts to quantify the odds. It multiplies factors like star formation rates, planets per star, and the chance of life emerging. Even using conservative estimates, the math suggests thousands of civilizations could exist in our galaxy alone. But reality shows zero evidence, not one definitive signal, not one artifact, not even a speck of alien machinery drifting through our solar system. This glaring absence has spawned dozens of theories, each more unsettling than the last. Take the Great Filter, a hypothetical barrier that prevents life from advancing to interstellar stages. Maybe it's lurking in our past. The leap from simple cells to complex life could be astronomically rare, or worse, it's ahead of us. Perhaps every advanced civilization hits a self-destruct button: climate collapse, nuclear war, rogue AI that we haven't faced yet. The filter's position determines whether we're cosmic miracles or doomed novices. Then there's the zoo hypothesis, the idea that aliens observe us like creatures in a galactic nature preserve. They might be avoiding contact to let humanity develop naturally or to protect themselves from our chaos. Others propose we're searching wrong. Advanced civilizations could communicate via neutrino beams or quantum entanglement, technologies we can't yet detect. Recent exoplanet discoveries only deepen the mystery. The Kepler telescope revealed thousands of worlds in the Goldilocks zone where liquid water and possibly life could exist. TRAPPIST-17 Earth-sized planets or Proxima Centauri b, just 4 light-years away, prove habitable real estate isn't rare, so why no neighbors? Either we're catastrophically alone or the universe is hiding something profound. The paradox forces us to confront a humbling truth: either we're the first, the last, or missing a fundamental piece of the puzzle. Until we know, the stars keep their secrets and the silence grows louder. In the sprawling tapestry of the cosmos, where galaxies cluster like glittering cities, there exists a desert so vast it defies comprehension, a region of space where almost nothing exists. This is the Boötes Void, a spherical abyss spanning 330 million light-years, so empty that if you stood at its center, you'd see only darkness in every direction. Astronomers call it the Great Nothing, and its discovery in the 1980s shattered assumptions about how the universe structures itself. The story begins with astronomer Robert Kirshner, who was mapping galaxy distributions when he stumbled upon a gaping hole in the constellation Boötes. At first, his team thought it was an error, a glitch in the data, but further observations confirmed the unthinkable: a cosmic void containing fewer than 60 galaxies where there should have been thousands. To put that in perspective, a typical region of that size would host around 2,000 galaxies. The Boötes Void isn't just sparse, it's a ghost town on a scale that rewrites our understanding of cosmic architecture. So how does such a void form? One leading theory involves the remnants of an ancient cosmic bubble. During the universe's infancy, fluctuations in density may have created vast, empty regions as space rapidly expanded. Think of it like foam in a bubble bath, where the walls of the bubbles are galaxy clusters and the interior is near nothingness. Another possibility is that smaller voids merged over billions of years, swallowing galaxies in a gravitational tug of war until almost nothing remained. But there's a darker, more speculative idea, one that fires the imagination. Could the Boötes Void be evidence of a Type 3 civilization? On the Kardashev scale, such a civilization would harness the energy of entire galaxies, potentially leaving behind sterile regions as they expand. It's a fringe theory, but the sheer unnaturalness of the void makes it irresistible to ponder. After all, nature abhors a vacuum, yet here lies the largest one we've ever found. What makes the Boötes Void so haunting isn't just its emptiness, it's the questions it forces us to ask. Are we seeing the aftermath of a cosmic accident or a footprint of something beyond our current physics? For now, it remains one of the universe's most profound puzzles, a silent, yawning gap in the stars, reminding us that even in a crowded cosmos, there are places where the rules don't seem to apply. In the constellation Monoceros, 700 light-years from Earth, a cosmic structure so precise it looks machine-made floats against the blackness of space. This is the Red Rectangle Nebula, a glowing, geometric enigma surrounding the aging star HD 44179. Unlike the chaotic, billowing clouds of most nebulae, this one forms an almost perfect X shape, with ladder-like rungs of dust and gas stretching between its crimson walls. Hubble's razor-sharp images reveal a structure so symmetrical it seems sculpted, not born from the usual stellar winds and explosions. The mystery begins with the star itself. HD 44179 is a post-main, sequence binary two stars locked in a tight orbital dance, one of them shedding its outer layers in violent pulses. These ejected materials should form the irregular, expanding shells typical of planetary nebulae. Instead, they've arranged themselves into this startlingly angular formation. The leading theory, the binary stars' gravitational interactions are funneling debris into opposing cones, creating the X-shape we see. But even that doesn't fully explain the nebula's bizarre, rungs, equally spaced dust bands that resemble steps on a cosmic ladder. Then there's the color. The red rectangle's eerie glow comes not from ionized gases like most nebulae, but from complex organic molecules called polycyclic aromatic hydrocarbons. These carbon-rich compounds, often found in soot and interstellar dust, fluoresce under starlight, painting the nebula in deep crimson hues. Stranger still, the nebula contains an unusually high concentration of these molecules, some of which are precursors to life's building blocks. It's as if the dying star is weaving chemistry's raw materials into this surreal geometric tapestry. What fascinates astronomers most is the nebula's defiance of time. Most planetary nebulae disperse within 50,000 years, but the red rectangle has stubbornly maintained its shape for millennia. Some suggest its dense dust lanes act as a shield, slowing erosion. Others speculate the binary star's precise interactions keep replenishing the structure. Whatever the reason, this cosmic artwork won't last forever. As the central stars continue to evolve, their radiation will eventually blow the nebula apart, erasing one of the universe's most meticulously crafted anomalies. For now, the red rectangle stands as a testament to nature's ability to surprise us. In a universe where chaos reigns, here's a structure that insists on order, a fleeting masterpiece etched in stardust and mystery. Its very existence whispers a tantalizing question. If something this precise can emerge from cosmic randomness, what other wonders defy our expectations? At the heart of the massive galaxy Messier 87, an insatiable cosmic predator lurks. This isn't just any black hole. It's a supermassive monster weighing in at 6.5 billion times the mass of our Sun, and it was caught red-handed in the act of galactic cannibalism. The evidence, a colossal jet of plasma stretching 5,000 light-years into space, a smoking gun signaling the violent feast happening below. But this isn't just a tale of destruction. It's a story of cosmic rebirth where galaxies grow, evolve, and prove Einstein right in the most spectacular way possible. The drama began billions of years ago when a smaller galaxy wandered too close to Messier 87's gravitational pull. Like a spider ensnaring prey in its web, the supermassive black hole at M87's core began tearing the intruder apart. Stars were ripped from their orbits, gas clouds shredded into streams, and immense tides of matter spiraled toward the black hole's event horizon. Some of this material didn't disappear quietly. Instead, it got caught in the black hole's powerful magnetic fields, funneled into jets moving at nearly the speed of light. These jets, visible across the electromagnetic spectrum, became the telltale sign of the black hole's gruesome meal. Then, in April 2019, humanity got its closest look yet at this cosmic devourer. The Event Horizon Telescope, a global network of radio observatories acting as one Earth-sized dish, captured the first ever image of a black hole's shadow. The now iconic photo showed a glowing ring of hot gas swirling around M87's abyss, precisely matching the predictions of Einstein's general theory of relativity. The shape, the size, even the way light bent around the black hole's gravitational well, all of it confirmed equations written over a century ago. But the real surprise was the asymmetry in the ring, a clue that the black hole was spinning, dragging space-time around it like a whirlpool. What makes Messier 87 so extraordinary isn't just its violence, it's how common this process actually is. Astronomers now believe most large galaxies, including our own Milky Way, grew through similar mergers. Galactic cannibalism isn't the exception, it's the rule. When two galaxies collide, their black holes eventually sink to the center of the new system, merging into an even larger beast. Sometimes, as with M87, the black hole's feast powers these dazzling jets. Other times, the meal is quieter, with gas and stars simply adding to the galaxy's bulk. Either way, these events shape the universe's structure, building the giant ellipticals we see today from countless smaller pieces. Yet Messier 87 still guards secrets. That 5,000 light-year jet, it flickers unpredictably, suggesting the black hole's feeding habits are far from steady. Some researchers suspect smaller, ongoing nibbles, perhaps the remnants of past mergers, are still falling in, stirring up turbulence. Others point to the jet's bizarre kinks and bends, evidence of magnetic battles happening near the event horizon. One thing's certain, this cosmic cannibal isn't done teaching us. Every observation peels back another layer, revealing how black holes shape their galaxies, how they warp space-time, and how, in the end, even the universe's most destructive forces are also its greatest architects. 50 light-years away, orbiting a sun-like star in the constellation Cancer, there's a world that makes Earth's most extravagant treasures look like pebbles. Welcome to 55 Cancri E, a planet so dense, so carbon-rich, that scientists believe it's quite literally made of diamond. Twice the size of Earth, but 8 times as massive, this glittering enigma defies every expectation of what a planet can be. Its surface, a scorching 2,700 degrees Celsius, hot enough to melt iron. Its composition, so packed with carbon that, under extreme pressure, it's likely crystallized into a vast planetary-scale gemstone. The first clues to this planet's bizarre nature came from its orbit. 55 Cancri E races around its star at breakneck speed, completing a full revolution in just 18 hours, so close that its surface is likely a molten wasteland of bubbling carbon. But it wasn't until astronomers measured its density that the real shock emerged. Despite its size, the planet weighed far more than a rocky world like Earth should. The math pointed to an unthinkable conclusion. This wasn't a ball of silicon and oxygen. It was a carbon empire with graphite layers stretching across its surface, and deeper down, a mantle of compressed diamond hundreds of miles thick. How does such a world form? The answer lies in its star system's unusual chemistry. Most stars like ours are oxygen-rich, birthing planets with rocky cores and silica crusts. But 55 Cancri is carbon-heavy, meaning its planets formed from carbon's building blocks instead. In this environment, carbon monoxide and methane ices clumped together during the system's birth, creating a protoplanet that was essentially a massive diamond in the rough. Over time, gravitational forces and radioactive heating melted its interior, allowing diamond to crystallize under pressures 1,000,000 times greater than Earth's atmosphere. Yet the most tantalizing question remains: what does this diamond world actually look like? Telescopes can't yet image its surface, but models paint a surreal picture. Some suggest rivers of molten graphite flow across plains of solidified diamond, while others propose a volcanic landscape where carbon erupts as diamond-rich magma. One theory even speculates that the planet's dark side, tidally locked in eternal night, could harbor massive diamond icebergs floating on a carbon monoxide sea. The existence of 55 Cancri E doesn't just dazzle with cosmic bling, it rewrites planetary science. If carbon worlds like this are common, the universe might be teeming with planets made of substances we'd consider precious. It's a reminder that beyond our solar system, the rules of chemistry and geology can twist into forms more fantastical than fiction. And while we'll never mine this distant gem, its very existence proves the cosmos has a flair for the extravagant. Who knows what other jewels are hiding in the dark? In the year 1572, Danish astronomer Tycho Brahe stepped outside on an ordinary November evening and saw something that would change astronomy forever. A new star blazing in the constellation Cassiopeia, shining brighter than Venus. To a world that still believed the heavens were unchanging, this was heresy. Stars weren't supposed to appear out of nowhere, yet there it was, visible even in daylight for weeks before slowly fading from view. Tycho's meticulous records of this stellar nova marked the birth of modern astronomy, proving the cosmos was alive with change. But what he witnessed wasn't just a new star, it was a violent death cry. A supernova, and 4 centuries later, we discover something even more astonishing, the star that refused to die. Today, we know this cosmic spectacle as Tycho's supernova, the ghostly remnant of a white dwarf star that tore itself apart in a cataclysmic explosion. But when astronomers trained the Chandra X-ray Observatory on its debris field, they found something inexplicable. Amid the expanding bubble of stellar wreckage, a faint pinpoint of light stubbornly persisted. This wasn't just glowing gas, it was the surviving core of the original star, still intact after unleashing enough energy to outshine an entire galaxy. A cosmic zombie back from the dead, the discovery shattered decades of supernova theory. Type Ia supernova, the kind Tycho witnessed, were supposed to be thermonuclear doomsday events where white dwarfs, the dense cores of dead stars, cross a critical mass limit and detonate completely. Nothing should remain, yet here was proof that some white dwarfs could endure their own apocalypse, clinging to existence even after expelling their outer layers at 20 million kilometers per hour. How the leading theory suggests the explosion may have been lopsided, rocketing the star's core away like a cosmic cannonball while the rest detonated. Alternatively, the dwarf might have siphoned material from a companion star unevenly, leaving pockets of unburned fuel at its core. But the real surprise came when astronomers analyzed the survivor's composition. This zombie star wasn't just any remnant. It was rich with heavy elements like silicon and iron, forged in the supernova's furnace. That meant it hadn't merely dodged destruction. It had been fundamentally reshaped by the explosion, like a blacksmith hammering molten metal into something new. Even more bizarre, its velocity showed it had been kicked away from the supernova's epicenter at over 500 kilometers per second, leaving a wake of shocked gas in its path. Tycho's supernova remnant now spans 20 light-years, its shock waves still rippling through interstellar space. Yet at its heart, that faint, defiant ember continues to burn, challenging everything we thought we knew about stellar death. It's a reminder that in the universe, even the most violent endings can leave survivors, and that sometimes the stars themselves refuse to follow the script. In the constellation Gemini, a star dances to an unseen partner's tune, but this isn't a cosmic waltz. It's a frantic, lopsided orbit around something invisible, something that shouldn't exist. Meet LB1, the black hole that broke the rules. When astronomers first tracked this star's erratic path in 2019, they expected to find a typical stellar mass black hole, perhaps 20 times the Sun's mass. Instead, the math revealed a monster, 70 solar masses, a gravitational Goliath so large it defied every model of how black holes form. The discovery hinged on a technique as old as astronomy itself, watching for wobbles. Just as planets tug their stars slightly off-center, LB1's invisible bulk yanked its companion star into a lopsided orbit detectable from Earth. But when researchers calculated the force needed to create that wobble, the numbers didn't make sense. According to current theories, stars between 65 and 130 solar masses should die in pair instability, supernova explosions so violent they leave nothing behind, not even a black hole. Yet LB1's mass sits squarely in that forbidden range, a cosmic rebel that somehow cheated death. So how did this impossible black hole form? One theory suggests it might be the product of 2 smaller black holes merging in a dense stellar cluster, their combined mass surpassing theoretical limits. Another posits that LB1 swallowed enormous amounts of gas and stars over eons, ballooning to its current size through relentless cosmic gluttony. But the most tantalizing idea involves dark matter hypothetical particles called WIMP could theoretically collapse into primordial black holes during the universe's infancy, bypassing stellar death entirely. If LB1 formed this way, it wouldn't just rewrite black hole science, it could solve one of cosmology's biggest mysteries. The implications ripple far beyond Gemini. If LB1 isn't alone, if the cosmos harbors more of these rule breakers, then our understanding of stellar evolution needs serious revision. Current models predict a mass gap between stellar mass black holes and supermassive ones, but LB1 bridges that gap effortlessly. Future observatories like LISA, designed to detect gravitational waves from merging black holes, might soon reveal whether LB1 is a cosmic oddity or the first of a hidden population. What makes this discovery so thrilling isn't just the black hole itself, it's the humility it demands. The universe keeps handing us paradoxes that force us to rethink the textbooks. LB1 stands as a stark reminder that for every law we write about how stars live and die, the cosmos has a way of scribbling in the margins, and tucked within those scribbles might be the secrets of how black holes, and perhaps the universe itself, truly work. Hidden in the constellation Coma Berenices, a ghostly galaxy floats like a cosmic mirage, visible yet barely there. Dragonfly 44 isn't just unusual, it's a celestial paradox. Packing roughly the same mass as our Milky Way, this behemoth should blaze with the light of 100 billion stars. Instead, it emits a feeble glow with only 1% of the stars we'd expect. The reason Dragonfly 44 isn't just a galaxy, it's a vault of secrets made almost entirely of dark matter. The discovery came in 2015 when astronomers using the Dragonfly telephoto array, a cluster of modified camera lenses designed to spot ultra-faint objects, noticed a smudge of light where no galaxy should exist. Most dim galaxies are dwarfs, tiny and low mass. But Dragonfly 44's stars moved far too quickly for its visible size, hinting at an invisible anchor holding them together. The math was staggering. 99.9% of this galaxy's mass couldn't be seen. It was dark matter incarnate, a shadowy skeleton with just a whisper of starlight draped over it. This revelation turned galaxy formation theories inside out. Normally, dark matter acts as a scaffold, attracting gas that ignites into stars. The more dark matter, the more stars, or so we thought. Dragonfly 44 breaks that rule. Its dark matter halo is as massive as the Milky Way's, yet it spawned almost no stars. One theory suggests it's a failed galaxy, where gas was somehow stripped away before star formation could begin. Perhaps it drifted through a cluster's hot plasma, robbed of its raw materials. Others propose it's a relic from the early universe, where dark matter clumped differently, creating these star-starved anomalies. Even its structure defies expectations. Unlike spiral galaxies with their bright arms or ellipticals with their dense cores, Dragonfly 44 is diffuse, a wispy collection of aging stars drifting in a vast, invisible grip. Its few stars are ancient, suggesting it's been dormant for billions of years. Yet it hasn't torn apart. That's the power of dark matter, an unseen hand keeping the galaxy intact against all odds. What makes Dragonfly 44 so revolutionary isn't just its existence, it's what it implies. If this galaxy isn't alone, if the cosmos is littered with these dark matter dominions, then our models of cosmic evolution are missing a crucial piece. Are these galaxies fossils of a stranger, more shadowy universe? Or are they evidence that dark matter behaves in ways we've yet to imagine? For now, Dragonfly 44 hovers in the dark, a silent challenge to everything we think we know. And as telescopes grow sharper, we might just find its silence speaks volumes. For centuries, Earth's moon has been a silent companion, its cratered face appearing unchanging to the naked eye. Yet look closer through the lenses of telescopes or the eyes of astronauts, and you'll find it's anything but still. Mysterious flashes of light, sudden glows, and shifting patches of color have been recorded on the lunar surface since at least the 12th century, when medieval monks reported fire and sparks bursting from its dark plains. These aren't just tricks of the eye, They're lunar transient phenomena, fleeting events that defy easy explanation, and they've puzzled everyone from backyard stargazers to NASA scientists. The anomalies take many forms. Some observers describe pinprick flashes like cosmic camera bulbs going off in the void. Others report reddish or violet hazes lingering over craters for hours. Apollo astronauts added first-hand accounts to the mystery. 11 crew members, including Buzz Aldrin, documented unexplained glows during their missions. Aldrin himself spotted a strange luminosity near the crater Aristarchus, describing it as a bright area with a slightly different color than the surrounding terrain. These weren't hallucinations. Instruments on the Lunar Reconnaissance Orbiter have since detected ultraviolet flashes in the same regions, confirming something tangible is happening. So what's causing these lunar light shows? One leading theory points to outgassing pockets of radioactive radon or other gases trapped beneath the surface, suddenly escaping through cracks and interacting with solar wind. When charged particles hit these gases, they could ignite brief auroras on the airless moon. Another possibility involves electrostatic activity. The moon's surface, bombarded by solar radiation, builds up powerful static charges. If these discharges leap between dust grains or rocks, they might spark visible flashes. Then there's the meteor impact explanation. Tiny space rocks, some no larger than pebbles, slamming into the moon at cosmic speeds and vaporizing on impact, creating momentary bursts of light. But not all cases fit neatly into these boxes. Some glows linger too long. Others recur in the same spots, like the crater Plateau, which has flared up over 160 times since the 18th century. A few researchers even speculate about moonquakes, tectonic shifts grinding rocks together, generating triboluminescence, the same eerie glow produced by grinding sugar cubes in the dark. The truth might be a mix of all these factors, or something we haven't yet imagined. What's certain is that our moon, often dismissed as a dead rock, still harbors secrets. Every flicker, every unexplained glow is a reminder that even the closest celestial body to Earth can still surprise us. And with new missions like Artemis set to return humans to the lunar surface, we might finally get answers or uncover even deeper mysteries hidden in the moon's ancient dust. Stretching across 150 light-years of interstellar space, a celestial specter reaches out with skeletal fingers, a ghostly hand frozen mid-grasp against the cosmic darkness. This is PSRB 150958, a pulsar nebula so eerily perfect it's been nicknamed the Hand of God. At its core lies a spinning neutron star, the collapsed remnant of a supernova that exploded 1700 years ago, rotating nearly 7 times every second. With each dizzying spin, it whips charged particles into space at nearly the speed of light, sculpting them into this haunting X-ray silhouette through forces we're only beginning to understand. The effect is both beautiful and brutal. The pulsar's intense magnetic field, 15 trillion times stronger than Earth's, acts like a cosmic particle accelerator, funneling electrons and ions outward along its poles. These particles slam into surrounding gas clouds left behind by the supernova, making them glow in high-energy X-rays. Over centuries, the outflow has carved delicate tendrils and cavities, creating the illusion of bony fingers stretching toward some unseen celestial prey. NASA Chandra X-ray Observatory captured this phantom limb in vivid detail, revealing structures so finely tuned they seem almost intentional, yet they're purely the work of physics. What makes this nebula so captivating isn't just its shape, it's a time machine. The pulsar at its heart is a newborn by cosmic standards, giving astronomers a front-row seat to how neutron stars reshape their surroundings. The nebula's twisted magnetic fields and turbulent particle flows offer clues about how heavier elements, the building blocks of planets and life, get scattered across the galaxy after a star's violent death. Every swirl and ripple in this X-ray portrait tells a story of energy transfer on a scale we can barely comprehend. Culturally, the hand of God has become more than just a scientific curiosity. Its uncanny resemblance to human anatomy sparks wonder at how the universe occasionally mirrors our own forms. Some see it as a metaphor for the delicate touch behind cosmic creation, while others interpret its grasp as a reminder of nature's relentless power. Whether divine coincidence or simple pareidolia, our brain's tendency to find familiar patterns, the image resonates because it bridges the vast, impersonal cosmos with something intimately recognizable. Yet beneath its poetic allure lies a harsh reality. That glowing hand is the aftermath of catastrophe, a star torn apart by its own gravity, now sending out a lighthouse beam of radiation that could sterilize planets light years away. It's a reminder that the universe's most breathtaking art often comes from its most destructive forces, and as the pulsar gradually slows, its spectral hand will eventually fade, dissolving into the interstellar medium like smoke on the cosmic wind, a fleeting masterpiece written in particles and light. Drifting alone through the eternal night between stars, a world without a sun tumbles through the void like a cosmic castaway. This is CFBD Sir 214904003, a rogue planet untethered from any star, wandering the galaxy at the mercy of gravity's unseen currents. Unlike Earth basking in the warm embrace of our sun, this orphaned world knows no dawn, no seasons, no gentle starlight. It exists in perpetual twilight, its surface bathed only in the faint glow of distant galaxies and the occasional flicker of passing stars. Detecting such loners is like spotting a single ice cube floating in the ocean at night. Without a host star's backlight, they're nearly invisible to traditional planet hunting methods. Astronomers found this particular wanderer through its faint infrared signature, a whisper of heat left over from its formation, radiating into the frigid vacuum. Even then, it took the combined power of the Canada-France-Hawaii telescope and the Very Large Telescope in Chile to confirm its existence. The numbers are staggering. At roughly 4 to 7 times Jupiter's mass and 130 light-years away, it's one of the closest rogue planets we've ever spotted. So how does a planet end up exiled from its solar system? The leading theory is brutal gravitational chaos. In a young star system, close encounters between massive planets can slingshot one of them into interstellar space like a stone from a catapult. Alternatively, CFBD Sir 214904003 might not be a planet at all, but a failed star. Brown dwarfs, objects too massive to be planets but too small to ignite hydrogen fusion, sometimes form alone in collapsing gas clouds. This cosmic drifter's temperature, around 400 degrees Celsius, blurs the line between planet and brown dwarf, making its true nature a puzzle. Yet the most fascinating question isn't where it came from, it's what exists on its eternal night side. With no star to warm it, the planet's atmosphere, if it has one, might collapse into strange, frozen forms. Some models suggest metallic hydrogen lakes or diamond rain could form under such extreme cold and pressure. Others speculate about hypothetical life clinging to geothermal vents beneath an ice-crusted surface, drawing energy from the planet's internal heat like deep-sea organisms on Earth. Rogue planets might outnumber stars in our galaxy, invisible nomads drifting unnoticed through the darkness. Each one is a time capsule from a shattered system, carrying secrets of cosmic violence and resilience. And as telescopes grow more sensitive, we're beginning to see just how crowded the interstellar highways really are, worlds without suns, forever adrift in the silent vastness between the stars. Nestled in the constellation Perseus, 220 million light-years from Earth, lies a cosmic relic so perfectly preserved it's like stumbling upon a living fossil. Only this one floats among the stars. NGC 1277 isn't just another galaxy. It's a time capsule, a shimmering island of ancient red stars frozen in a state that hasn't existed elsewhere for 10 billion years. While most galaxies evolve, collide, and recycle their stars in a dynamic dance, this one hit pause, defying every expectation of how galaxies mature. What makes NGC 1277 so extraordinary is its composition. Modern galaxies like our Milky Way are bustling stellar cities with neighborhoods of young blue stars, pockets of star-forming gas, and supermassive black holes at their hearts. But this relic galaxy skipped all that. Its stars are uniformly old red giants that formed in a single, intense burst shortly after the Big Bang then. Stopped, no new stars, no mergers, no fresh gas spiraling into fuel rebirth. It's as if the entire galaxy entered hibernation at the dawn of time and never woke up. The mystery deepens when you consider its surroundings. NGC 1277 lies in the densely populated Perseus cluster, a region where galaxies constantly interact, stealing gas and stars from one another. In such a chaotic environment, how did this galaxy remain untouched? One theory suggests it moved too fast, rocketing through the cluster like a bullet, never lingering long enough to be disrupted. Another possibility is that it exhausted its gas supply early, leaving nothing to form new stars. But the most tantalizing idea involves its supermassive black hole, a behemoth so massive it may have choked off star formation entirely, blasting away potential fuel with violent outbursts before the galaxy could rejuvenate. Yet the real puzzle isn't just why NGC 1277 froze in time. It's why we haven't found more like it. In a universe teeming with diversity, this galaxy stands alone, a cosmic hermit refusing to follow the rules. Astronomers have scanned thousands of galaxies, hunting for similar relics, but none match its pristine antiquity. That rarity makes it a Rosetta Stone for understanding galaxy evolution. What if the early universe birthed more of these frozen giants, only for most to be erased by collisions or internal chaos? Studying NGC 1277 is like peering through a keyhole into the universe's youth. Its crimson stars whisper secrets about an era when galaxies were simpler, when the cosmic recipe hadn't yet been complicated by mergers and recycled stardust. And as telescopes grow more powerful, this celestial relic may finally reveal why it chose solitude, and whether it truly stands alone or is just the first of many waiting to be found. Deep in the constellation Orion, a newborn star scribbles its uncertainty across the cosmos, not with words, but with twin jets of superheated gas stretching 3 light-years into space. This is Herbig Haro 24, a stellar nursery where physics and chance have conspired to create something astonishing, a perfect celestial question mark. The upper curve glows with the blue-white intensity of ionized hydrogen, while the descending dot blazes with the energy of a star fighting its way into existence. It's as if the universe itself paused mid-sentence, leaving astronomers to ponder its meaning. The science behind this cosmic punctuation is as violent as it is beautiful. At the heart of the structure lies a protostar, a baby sun barely 100,000 years old, still shrouded in the thick molecular cloud that birthed it. As gravity crushes the star's core to unimaginable densities, magnetic fields channel excess material into bipolar jets, twin fountains of plasma erupting at 700,000 kilometers per hour. These jets collide with surrounding gas, sculpting shock waves that illuminate the nebula like neon signs in a cosmic diner, the question mark's unique shape. A quirk of perspective, one jet points almost directly at Earth, appearing shorter and brighter, while the other curves away, its outer edge distorted by interstellar winds to form the elegant hook. But why does this particular formation captivate us so deeply? Beyond the physics, it's the symbolism that resonates. Astronomy is built on questions: dark matter, the Fermi paradox, the nature of time. And here, the cosmos seems to mirror our collective curiosity back at us. The irony isn't lost on scientists. A structure forged by the raw mechanics of star formation has become an emblem of the very mysteries it embodies. Zoom in further and the details grow stranger. The protostar's accretion disk, a swirling buffet of dust and gas, is tilted nearly edge-on from our viewpoint, creating dark bands that resemble the serifs of a typed question mark. Meanwhile, filaments of carbon monoxide twist through the jets like ink trails, their turbulent motion captured in eerie detail by radio telescopes. Some researchers speculate these filaments might be cosmic umbilical cords, remnants of the star's connection to its birth cloud before the jet severed it. The lifespan of this celestial glyph is fleeting. Within a few million years, the protostar will stabilize, its jets will fade, and the question mark will dissipate into the interstellar medium. But for now, it hangs in Orion's sword, a reminder that the universe communicates in symbols as much as in equations. And perhaps that's the most profound lesson of all sometimes. The cosmos doesn't just give us answers. It asks us to look deeper. 400 light-years from Earth, in the constellation Centaurus, there's a world where the sky defies all logic, a planet where 3 suns dance in an endless celestial ballet. Meet HD 131399b, an exoplanet so young and so chaotic that it makes Tatooine's twin suns look tame. Here, a newborn gas giant, barely 16 million years old, orbits the brightest of 3 stellar siblings while the other 2 stars pirouette around each other in the distance. The result, a sky where triple sunrises paint the clouds in impossible hues and shadows stretch in 3 directions at once. But this isn't just a cosmic light show. It's a gravitational tightrope act, one that should have torn the planet apart. The secret to HD 131399b's survival lies in its precarious orbit. Most multi-star systems eject planets early in their formation, flinging them into the void like cosmic spitballs. Yet somehow, this world found stability in chaos. Its primary star, HD 131399a, anchors it at a distance twice as far as Pluto is from our Sun, a vast buffer that keeps the planet from being yanked into oblivion by the 2 smaller stars orbiting farther out. But stable is a relative term. The planet's year lasts 550 Earth years, and for about a third of that time, all 3 suns are visible simultaneously, a never-ending daylight where the skies glow with overlapping halos. Then, as the planet continues its long loop, 1 star dips below the horizon, leaving a bizarre double sunset before the 3rd star finally vanishes, granting a fleeting night that lasts roughly a human lifetime. Imagine standing on this world. If its scorching 300 degrees Celsius temperatures and hurricane-force winds didn't vaporize you first. The largest sun would dominate the sky, a glaring orb 4 times brighter than our Sun. The 2 smaller companions would appear closer together, shimmering like fiery twins, sometimes eclipsing each other as they whirl around their shared center of gravity. During the rare periods when all 3 stars align just right, their gravity would stretch the planet's atmosphere into teardrop-shaped tides, stirring storms that could swallow Jupiter whole. What fascinates astronomers most isn't just the planet's defiance of orbital mechanics, it's the sheer improbability of its existence. Triple star systems are common, but planets within them are vanishingly rare. HD 131399b shouldn't have formed at all, yet there it is, a cosmic teenager kicking over the chessboard of astrophysics. Some theories suggest it might have been born around a single star before being captured by the trio, a stellar kidnapping frozen in time. Others propose its wide orbit is the only reason it survived, like a child staying just out of reach on a carousel gone haywire. Every observation of this chaotic trinity peels back another layer of mystery. The planet's atmosphere, rich in water vapor and methane, churns with turbulence unlike anything in our solar system. Its 3 parents bathe it in conflicting radiation, stirring chemical reactions that paint its skies in shades unknown. And as astronomers watch this celestial juggling act unfold, they're left with a humbling realization. The universe is far more inventive than we ever dreamed. A place where planets not only survive impossible conditions but turn them into something beautiful. For all our grand surveys and sky mapping missions, the universe has been quietly playing a cosmic shell game with its own building blocks. Here's the puzzle when astronomers tally up all the normal matter. The protons, neutrons, and electrons that make up stars, planets, and us, they come up shockingly short. Based on measurements of the cosmic microwave background and the universe's initial recipes, there should be about twice as much ordinary matter as we've actually found. This isn't dark matter we're missing. This is the stuff we're made of, seemingly vanished without a trace. The case of the missing baryons has haunted cosmology for decades, but the culprit might finally be emerging from the shadows, a ghostly web of superheated gas threading between galaxies. The prime suspect, a phenomenon called the warm-hot intergalactic medium, or WIM. Picture the universe's scaffolding, vast filaments of gas stretching between galaxy clusters like invisible spider silk, so tenuous that a cubic meter of this material might contain just a single atom. But what it lacks in density, it makes up for in sheer volume. Theoretical models suggest this diffuse web could account for every last missing baryon if only we could see it. The challenge: this gas is heated to temperatures between 100,000 and 10 million degrees, making it too hot to emit visible light yet too cool to glow brightly in X-rays like scorching galaxy clusters. It's the cosmic equivalent of trying to spot a whisper in a hurricane. Breakthroughs in detection are turning the tide. Astronomers have developed ingenious ways to hunt this phantom matter, like using distant quasars as backlights. As their light travels through WIM filaments, certain wavelengths get absorbed by oxygen atoms, a telltale fingerprint of the missing baryons. The XMM Newton and Chandra space telescopes have caught dozens of these absorption lines, mapping the WIM distribution. Even more compelling, the Planck satellite detected subtle distortions in the cosmic microwave background caused by WIM filaments bending light like frosted glass, revealing where the universe's hidden matter warps spacetime itself. But the WIM isn't just solving a cosmological accounting error, it's rewriting the story of how galaxies form. These filaments act as cosmic aqueducts, funneling gas into hungry galaxy clusters over billions of years. Without them, the universe's metropolitan centers, the glittering cities of stars we see today, would have starved long ago. The realization that most ordinary matter exists in this shadowy, in-between state flips our perception of the cosmos. We've been fixated on the sparkling streetlights while missing the dark highways connecting them. Yet mysteries linger. Current WIM detections still only account for about half the missing matter, suggesting either our instruments aren't sensitive enough or there's another reservoir we've yet to discover. Some theorize additional baryons could be hiding in even hotter, more diffuse gas, or perhaps in enormous but faint galactic halos. Others speculate about exotic forms of dense quark matter lurking in deep space. With next-generation telescopes like ESA's Athena mission set to launch in the 2030s, the hunt for the universe's lost matter is entering its most exciting phase. What makes this detective story so profound is what it reveals about our place in the cosmos. Every atom in our bodies was once part of this vast, invisible network, a thread in the tapestry we're only now learning to see. The missing baryons weren't missing at all. They were simply waiting for us to look at the universe in a new light. In the heart of the Large Magellanic Cloud, a satellite galaxy dancing around our Milky Way, a cosmic void stretches 325 light-years wide, not empty but sculpted by unimaginable forces. This is N44, a galactic superbubble where the collective fury of stellar winds and supernova has blasted a cavern in the fabric of space itself. Imagine a soap bubble the size of a city, but instead of delicate film, its walls are woven from shock waves and radiation, threaded with filaments of glowing gas. What makes this structure truly extraordinary isn't just its scale. It's the uncanny ring of young, blue stars sparkling along its rim like diamonds set in a cosmic bracelet. The story of N44 began millions of years ago with a stellar dynasty. Massive stars, dozens of times heavier than our Sun, lived fast and died violently. Their furious winds, charged particles streaming outward at millions of kilometers per hour, slowly pushed the surrounding gas outward, hollowing out space like a cosmic jackhammer. When these stars reached the end of their lives, they didn't fade quietly. They detonated as supernova, their final explosions delivering knockout punches that expanded the bubble even further. Layer by layer, eruption by eruption, N44 grew into the colossal structure we see today. But the real mystery lies in that sparkling stellar necklace. Young stars aren't supposed to form in the aftermath of such violence. Supernova typically blast away the gas needed for star birth. Yet here they are, clusters of hot, newborn suns defiantly lining the bubble's edges. One theory suggests that the very shocks that carved the bubble also triggered a chain reaction, compressing pockets of surviving gas until they collapsed under their own gravity, igniting new stars like sparks catching on dry tinder. It's a cosmic feedback loop, death giving birth to life on a staggering scale. Hubble's sharp eye has revealed even stranger details. The bubble's interior isn't perfectly hollow. Tendrils of cool gas stretch across the void, remnants of denser regions that resisted the onslaught. Meanwhile, X-ray telescopes detect a faint glow from gas heated to millions of degrees, still churning from ancient explosions. And at the bubble's heart, a lone surviving giant star, too massive to have avoided going supernova yet, stands as a silent witness to the chaos. N44 offers more than just a spectacle. It's a blueprint for understanding how stars reshape their environments. Similar structures pepper our own Milky Way, though none as pristine or massive. By studying this celestial balloon, astronomers glimpse how galaxies recycle their materials, how shock waves propagate through space, and how the cycle of stellar death and rebirth builds the universe we recognize today. And perhaps most humbling of all, it reminds us that even in destruction, the cosmos finds ways to create scattering starlight like seeds in the wind. At the edge of the observable universe, where time itself seems to fray into the primordial darkness, an impossible beacon pulses with the energy of 20 trillion suns. Oula's J1342 plus 0928 isn't just the most distant quasar ever discovered, it's a cosmic paradox, blazing to life a mere 690 million years after the Big Bang. This shouldn't exist. At that early epoch, the universe was still a toddler, barely weaned from its fiery birth. Yet here sits a supermassive black hole weighing in at 800 million solar masses, a gravitational Goliath that defies every model of how such monsters form. The discovery, made in 2017 by telescopes combing through infrared sky surveys, sent shockwaves through astrophysics. Quasars, the hyperactive cores of ancient galaxies powered by voracious black holes, are cosmic lighthouses, but this one shines from an era when the universe was only 5% of its current age. To grow so massive so quickly, this black hole would have needed to devour gas at the theoretical maximum rate for its entire existence, a feeding frenzy that strains the laws of physics. Even if it started as a massive seed, a hypothetical direct collapse black hole from the death of a primordial superstar, the math barely holds. It's like finding a skyscraper in the ruins of a civilization that only just discovered the wheel. What makes Oula's J1342 plus 0928 even more extraordinary is its environment. The quasar's light, traveling 13 billion years to reach us, carries fingerprints of the era when the universe was emerging from its dark ages. The moment the first stars and galaxies burned away the cosmic fog of neutral hydrogen. Yet this quasar's spectrum reveals something startling. The space around it was already largely transparent. Somehow, its radiation had begun reionizing its surroundings, punching holes in the primordial mist long before most models predict such clearing should have occurred. This wasn't just a passive relic of the early universe, it was an active participant in shaping it. The implications rewrite our understanding of cosmic dawn. If black holes this colossal existed so early, they must have formed through mechanisms we've yet to imagine, perhaps via exotic physics like super Eddington accretion, where black holes exceed their theoretical feeding limits, or through mergers of countless smaller black holes in densely packed star clusters. Some theorists even speculate about primordial black holes, forged in the chaos of the Big Bang itself, lurking as ready-made seeds for these cosmic anomalies. Yet the greatest mystery isn't how this quasar came to be, it's how many others like it are waiting to be found. With each new generation of telescopes, we peer deeper into the universe's infancy, only to discover it was far more dynamic and chaotic than we ever predicted. Euler's J1342 plus 0928 stands as both a milestone and a warning. The early universe didn't play by the rules we wrote for it. And as we stare into that impossibly ancient light, we're forced to wonder what other cosmic impossibilities are still hiding in the shadows of time. In the quiet spiral of galaxy NGC 7331, 60 million light-years from Earth, a star staged the greatest disappearing act in cosmic history, then returned for an encore. Supernova 2014c began like any other stellar explosion, flaring brightly in January of that year before dimming as expected. Astronomers classified it as a Type Ia supernova, the predictable thermonuclear detonation of a white dwarf star. Case closed until it wasn't. 3 months later, something impossible happened. The dead star roared back to life, surging in brightness as if it had exploded all over again. But this time, the spectral fingerprints told a different story. The explosion had morphed into a Type Roman II supernova, a violent core collapse event typically seen in massive, short-lived stars. One star, two deaths, a cosmic Jekyll and Hyde act that rewrote the rules of stellar demise. The key to this mystery lies in what happened between the explosions. When researchers trained NASA Chandra X-ray Observatory and the Very Large Array on the site, they uncovered a shockwave plowing through a dense shell of material 11,000 times Earth's mass worth of hydrogen-rich gas ejected by the star centuries before its final act. This wasn't just debris, it was a stellar cry for help. The doomed star had apparently tried to save itself by shedding its outer layers in a series of violent outbursts, like a drowning swimmer flailing to stay afloat. When those last-ditch efforts failed, the core collapsed inward, triggering the first explosion. Then, months later, the expanding shockwave from that blast slammed into the previously ejected material, heating it to millions of degrees and creating the illusion of a second explosion. What makes SN 2014c so revolutionary isn't just its two-faced nature, it's the glimpse it offers into stellar desperation. Most stars die quietly or explosively, but this one fought its fate tooth and nail, rewriting itself in the process. The transition from Type I to Type Roman II suggests the star existed in a twilight zone between categories, neither fully a white dwarf nor a red supergiant, but something in between, struggling to define its own destiny. The hydrogen shell it ejected, far richer than expected, hints at previously unknown stages of stellar evolution, where aging stars can essentially hemorrhage material in fits of cosmic instability. The implications ripple far beyond one bizarre supernova. If stars regularly shed such colossal amounts of matter before exploding, it could explain lingering mysteries like why some supernova appear dimmer than expected, or why certain remnants contain unexpected chemical signatures. SN 2014c proves that stellar death isn't always a clean one-and-done event. Sometimes it's a messy divorce, with the star tearing itself apart piece by piece before the final collapse. And with next-generation telescopes now scanning the skies for similar events, we may soon discover that this cosmic double feature wasn't a fluke, but the opening act of a whole new class of stellar behavior. In the end, SN 2014c leaves us with a humbling lesson. Even stars, bound by physics we think we understand, can defy expectations in their final moments. What we perceive as a single flash in the night might actually be the last, desperate chapters of a stellar autobiography written in shockwaves and resurrected light. From inexplicable signals to rogue planets, vanishing stars to celestial handprints, we've traveled through 25 of the universe's most baffling wonders, each one a humbling reminder that reality outshines even our wildest science fiction. These aren't just anomalies, they're cosmic breadcrumbs leading us toward deeper truths about black holes rewriting physics, ancient quasars defying time, and invisible matter weaving the fabric of space itself. Every strange flash, every impossible orbit, every silent galaxy is a question waiting to be answered, a door waiting to be unlocked. Consider how these mysteries shape human knowledge. The WOW signal made us rethink interstellar communication. Tabby's star forced us to imagine megastructures. The Great Attractor revealed our blindness to the universe's hidden architecture. Even failures become breakthroughs when theories collapse under the weight of new evidence. That's not defeat. That's science evolving in real time. The universe isn't playing tricks on us. It's inviting us to look closer, think bigger, and admit how much we still have left to discover. So, which of these cosmic riddles captured your imagination? Was it the diamond planet glittering in perpetual night, or the zombie star that refused to die? The nebula shaped like a question mark, or the black hole that broke all the rules? Drop your favorite in the comments. I read every response. And if your curiosity isn't satisfied yet, you're in good company. Hit subscribe and join me as we keep unraveling the universe's greatest mysteries, one mind-bending discovery at a time. After all, the cosmos never stops surprising us. The next revelation might be just a telescope click away.